Hi everyone, welcome back to another video in the Web Security Academy series. In the previous video, we covered lab number 6 in the SQL Injection module. So we got some hands-on experience by exploiting a union-based SQL injection in order to retrieve the usernames and passwords of the users of the application in a single column. In today's video, we'll be using a union-based SQL injection attack to query the database type and version on Oracle databases. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in. So to access the lab, I'm going to click on Academy. Go down, select Learning Path, go down again, select SQL Injection, go down one more time, and select Examining the Database in SQL Injection Attacks. Alright, so we'll be covering the first one, titled SQL Injection Attack Querying the Database Type and Version on Oracle. Alright, let's get started. This lab contains a SQL injection vulnerability in the product category filter. So we've got SQL injection, and it's in the product category filter. You can use a union attack to retrieve the results from an injected query. To solve the lab, display the database version string. So the end goal is to display the database version string. All right, and they give us a hint over here. We're not going to look at it just yet. Let's access the lab. We'll add an analysis section. Okay, so it says make the database retrieve the string that is displayed on the screen. So the version of the Oracle database. All right, so if we look at the application, it's the same or at least similar shopping application that we've been dealing with in the previous labs. If we click on gifts, so the category gifts, it refines our search on the items that are related to the gifts category. And we can see over here that the category parameter is included in the URL, and that's the field that is vulnerable based on the description of the lab. So to confirm that it is vulnerable, I'm gonna add a SQL character, a single quote that will result in a syntax error, which should result in an internal server error at the application level, and it does. Okay, so this looks like it's vulnerable to SQL injection. Now, whatever we enter in this field over here gets displayed on the page, and that's why we can use a union-based SQL injection to exploit this vulnerability. And to do that, we said there is 2 steps that you need to do before you can output data from the database. And the first one is to determine the number of columns that the vulnerable query is using. Now I can tell there has to be at least 2 columns because you could see over here each item has 2 entries. One is the title of the item and then the description of the item. So my assumption is there's 2 columns, but there could be other columns that are not displayed on the page, and that's why we have to test for that. And the way we do that is by using this payload over here. So order by and the column number. So when we order by a column, it should order the column on the page. And if we try to order by a column that does not exist, it should throw an internal server error. So we know there's at least 1 column because we can see it on the page. And so this should give us a 200 response code. Okay, so let's do that using burp. And for those of you that are not familiar, this is pretty much a man-in-the-middle proxy that sits between the browser and the application, and any requests that happen through the browser get sent to burp first before they get sent to the application, and any responses from the application get sent to burp first before they're sent back to the browser. All right, let's put this over here and click on the proxy tab. So you'll see over here it's set at localhost 8080. And I'm going to use my Foxy proxy extension to set it to send requests to burp. All right, and I'm going to click on gifts one more time. And you'll see over here, it intercepted the request. Now, since I'm going to be sending multiple requests, I'm going to send it to repeater, and I'm going to work from there. Okay, so let's turn off the proxy. And go back to repeater. All right. So let's copy our payload. And then do Control-U to URL encode it. Hit send. And we get a 200 response codes, confirming that we have at least one column. Now, if we do 2 and hit send, we also get a 200 response code, confirming that we have at least 2 columns. Now let's try with 3. And we get an internal server error. So let's write that down. What that means is that we're trying to order by a column that does not exist. And since we did this iteratively, that means that the number of columns that is used by the vulnerable query is 3 minus 1, which is equal to 2. All right, the second thing to do in a union-based SQL injection attack is to determine the data types of the columns. And we said we do that using a union select null query. So we know there's 2 columns. And what we're going to do is we're going to test each one using a text value or a string. And if the data type of this column is not compatible with the data type of the column that is used to filter on category, it should throw an error telling us that this column is not of type string. And if we don't get an error, that means that the column is also of type string. Now, if we go back to the application, you could see over here, both columns contain alphabets, and so they're both of type string. But let's test it out regardless, just in case. So I'm going to put both of them because my assumption is that both of them are of type string based on what we see in the browser. Okay, again, we need to URL encode it. Hit send. And I think we messed something up. So let me do this one more time. Okay, let's copy it. And we're missing a quote. And then Control-U to URL encode it. And hit send. Okay, so we're getting an internal server error again, which makes me think that this is an Oracle database, and I'll explain why in a second. So I should have known that based on just the lab description. It says querying the database type and version on Oracle, but I didn't read that properly. And the reason I think that this is an Oracle database is because I know for sure that these 2 columns are of type text based on the browser over here. However, this still gave me an internal server error, which does not make sense. And so what I'm going to do is I'm going to search Oracle select statement. Let's click on this entry over here. Okay, so it defines over here how you perform a select statement in Oracle databases. So it says select the number of columns from the table name. If you go down over here and click on Oracle Dual Table, you'll notice over here that it says in Oracle, the select statement must have a from clause. However, some queries don't require any table. So in this scenario over here, we don't have a from clause, and that's why this failed. Now, I don't know the tables that I want to extract from, and this is just me putting strings in the columns. And so I need some dummy table to use in the from clause in order to be able to confirm the data types of the columns. And over here, you'll see that it says Oracle provides you with a dual table, which is a special table that belongs to the schema of the user sys, but it is accessible to all users. And so you could use it in scenarios like this, where the data that you're outputting is not actually coming from a table. So let's try this over here. And then we'll do Control U to URL encode it. Hit send, and we get a 200 response. So now we know for sure that this is an Oracle database. And then if you go down, you should see A and A. So the content being outputted on the page. All right. So those are the first two steps in a union-based SQL injection. The next thing to do is to output the version of the database. Okay, and to do that, we're going to go back to the exercise and look at the hint section, because there you'll find a SQL injection cheat sheet, which tells you what the command is for outputting the version on each type of database. So if you go down, and then in the section database version, it tells you how to output the database version when it comes to Oracle databases, when it comes to Microsoft databases, when it comes to MySQL databases, and so on. So we're looking for this one over here, since we know it's Oracle based on the fact that it threw an internal server error when we didn't enter a table name. So the command is over here. Okay, but we have to put that in our union-based SQL injection attack. So it would be union, select the banner, and then over here, it's still two columns, so we still have to put a value. So null in the second column, and then we're going to say from the $ version, and then the comment characters, and let's copy that. And put it over here. And then again, you need to URL encode it. That's Control U, hit send, and we get a 200 response code. Okay, so let's go down and see if we actually outputted the version. Okay, let's make that a little bit bigger. So you'll see over here, it started outputting the content. And the exact version we're looking for is this one over here. So Oracle Database, 11G, Express Edition Release, and so on. And if we go back to the page, it should say, congratulations, you've solved the lab. All right, so we've successfully completed the exercise. Now let's script it. Okay, so the first thing to do is to import the requests library. What that does is it allows you to make get and post requests. Next, we'll import the sys library and URL lib3. We'll also add this line over here to disable any warnings that are related to insecure requests. So URL lib3 dot exceptions dot insecure request warning. And let's click on view and toggle word wrap. All right, so let's write our main method. And then the try and except clause. All right, so the way I want my script to run is I'm gonna say script.py and give it the URL, and then it'll perform the SQL injection exploit for me. Now, I'm not gonna do step number 1 and step number 2 because we've done it in previous labs, and so I'll leave that as an exercise. Instead, I'm going to assume we know the number of columns and we know which columns we can use in order to output content from the database, and we're just going to use the script to output the version of the database. So we're going to take from the command line arguments the URL of the application, and we do that using sys.argv one.strip. Okay. And then if I don't give it the URL, I want it to print the usage instructions and an example of how to run the application. So name of the program and URL. And then let's print an example just so that we can make it clear. .example.com, and again, name of the program. And then we exit the program because we didn't run it correctly. All right, so now assuming that we gave it the correct number of arguments and the URL was saved in this parameter over here, the next thing I wanted to do is print this statement over here. So dumping the version of the database. And then I'm going to create a function called exploit SQLi version, and it takes in the URL. If that function returns false, I'm going to print unable to dump the database version. All right, so if the function returns false, we print the statement unable to dump the database version. Okay, so let's implement this function over here. So actually, before we do that, we forgot to set our proxy setting, which is super important when debugging our script. So that's done using HTTP 127.0.0.1, because that's how our proxy is set. And we'll do that for HTTPS as well. This way, any requests that this script makes get sent to burp. And now if my program doesn't run or acts in a different way than expected, I could just look at the requests and debug the script. All right, so now let's write the function. So exploit SQLi version. Again, it takes in the URL. Now we have to build our request. So the path was this one over here, filter category, and it was on gifts. Okay, the SQL payload was equal to the one we wrote over here. Let's copy that. Okay, and then we're making a GET request. And the reason I'm making a GET request is because that's what the application makes. And then we take in the URL, concatenate the path, and the SQL payload. All right, set verify to be equal to false because I don't want to verify certificates, and proxies is equal to proxies so that the request gets sent to burp in case I need to debug it. And then I'm going to set the response to be saved in the parameter res. Okay. Now I need to figure out if the SQL injection worked, and I'll do that based on the content of the response. So if the response has the string Oracle database in it. So we'll see that there's only one match over here. That means that the SQL injection worked because it dumped the version of the database. So I'm going to say if Oracle database is in the response, then print found the database version. And now I don't want it to just say that it found the database version. I also want it to extract it from the response and output it on the command line. And so to do that, we're going to import two more libraries. So from BS4, import beautiful soup, and also import the regular expressions library. So this will help us parse the response and extract the version from there. So we'll do soup is equal to beautiful soup, and that's the response over here that we saved. And then we'll use HTML parser. Okay, and now the version would be equal to soup.find the text re.compile, so we're using a regular expression. And what we're looking for is anything that starts with any number of characters, as long as you find the string Oracle space database. So the back quote S stands for space over here, and then it ends with any number of characters. All right. And then what it's going to do, it's going to print the Oracle database version is, and the version over here. So what we saved in this parameter over here, and then it'll return true. Otherwise, it'll return false. Okay. Let's save that. Open up a terminal. And hopefully it won't have any errors. So that's Python 3 SQLi lab 07.py. And the URL of the program, I'm not sure it's still running. Yeah, so it timed out. We're going to have to open it again. Okay, let's take the URL, copy, paste, remove the slash over here because we already include it in our path, and hit enter. Okay, so we got an error, although it said that it solved the lab. Let's find out why. So line 33. Okay, so I think I know what's wrong. This was written incorrectly. So the regular expression. So whenever you're writing a regular expression, you're not sure if it's correct. What you could do is just go to regex 101 and confirm that it's correct over there. So I'm going to copy this. Okay, it looks like the regular expression is correct. Now I want to confirm that it will find the database version through it. So what was it? Let's copy the request again in proxy. Hit gifts, send it to repeater, and exploit it one more time. And do Control U to URL encode it. Hit send. Okay, and I'm looking for this over here and it says 0 matches. Oh, and that's because we're looking for this one over here. Hit send. Okay, it found one match. Okay, so this is the string that I'm trying to match on. And so what I'm going to do is I'm going to copy the entire string, put it in regex 101, and see if it matches on it. Now you could see over here it says one match, and what that means is that your regular expression that is put over here matches on this string over here, and so the program should work. All right, so I'm going to save it, go back to burp, put request off, just so that it doesn't interfere with things, clear this, and hopefully this should work. Let's go to our history tabs so that we see it in real time happening. Hit enter. Okay, so you could see over here it says dumping the version of the database. It found it based on the regular expression that we gave it. And then it says the Oracle database version is this string over here. And you'll see the request that it made is this one over here. And then again, if we search on that string, we find it. All right, so we've successfully completed the exercise. To recap, in this video, we first manually ran a SQL injection union attack that allowed us to query the database type and version on an Oracle database. We then scripted the exploit so that it automatically does that for us. In the next lab, we'll learn how to exploit a union-based SQL injection vulnerability in order to query the database type and version on Microsoft and MySQL databases. If you liked the video, hit the subscribe and share button so that it reaches a wider audience. Also comment below what you learned and what you would like to see more of in the future. Thank you and see you in the next video.